Good day, everyone. Today is another lucky day for all of us, that we were given another day and chances to study and learn science, particularly physics. That today we will be discussing motion. Describe motion in terms of change in position, the rate of change in position, and how fast the rate of change in position is done. Today we will discuss and describe motion. In the following figures is the body in motion. Can you precisely say that the man is in motion? Is there any change in the position of the man? How do you know there is a change in the position? In this figure, there is a tree and the man's positions with respect to the tree are shown. Is the man in motion? Are there changes in position? In which figure the man is in motion? In this figure with the tree, there is a change in the position of the man in every unit of time. Thus, the man is in motion with respect to the tree. Let's determine if the body is in motion. Is the man in motion with respect to the tree? If you say yes, then you are correct. The man is in motion with respect to the tree, because there is a continuous change in the position of the man with respect to the tree. Next, is the car in motion with respect to the tree? Yes, the car continuously changes position with respect to the tree. How about the man with respect to the car? Is the man changing position with respect to the car? If you say no, then you're right. The man maintains the position with respect to the car while moving away from the tree. Thus, he is not in motion with respect to the car. So in describing the motion of the body, there must be a frame of reference. How is the motion defined based on these illustrations? Motion is the continuous change in the position of the body with respect to a stationary frame of reference. The change in the position of the body can be uniform or changing. The man is in this illustration changes position with respect to the tree, and the change in the positions are the same. The man has uniform motion. The man in this figure changes position that increases as the motion progresses. This is an accelerated motion. The space between the man and the tree continuously increases. A body in motion can be described in terms of distance traveled x, which is the change in the position of the body. For example, a man runs 10 meters in every 1 second. Or displacement s, which is the change in the position of a body in a particular direction. Example, a man runs 10 meters away from the tree in every 1 second. The next question is, are the magnitudes of distance traveled and displacement the same? If not, when are the magnitudes of distance traveled and displacement the same? Is it possible for displacement to be greater than distance traveled? In this figure, the man runs in the same direction from time sub 0 to time sub 4. How do the distance traveled and displacement compare? The distance traveled of the man after time sub 4 is 40 meters, and the displacement is equal to 40 meters away from the tree. Thus, the distance traveled and displacement have the same magnitudes. What is the distance traveled and displacement after time sub 8? Note that the direction changed after time sub 4. The distance traveled of the man after time sub 8 is 80 meters. The displacement of the man is 10 meters away from the tree. What can you say about the magnitudes of distance travel and displacement? In a unidirectional motion, the displacement and distance traveled have the same magnitudes, but not when the body changes its direction. The magnitude of distance traveled is greater than the displacement when the direction of the motion changes. Distance traveled or displacement is a measure of length. Thus, the units of these quantities in the three systems are meter in the NKS system, centimeter in the CGS system, and feet in the FPS system. Other commonly used units are kilometer, millimeter, inch, yard, and mile. From this tree, the man is running away and the distance from the tree continuously increases. Notice that the change in position in every unit of time are all 10 meters. The change in the position of the body divided by the time taken to change the position, or x over t in formula, is the speed of the body. If we describe this change in position in reference to a frame of reference, this is velocity. When computed, the speed of the man is 10 meters per second. A body in motion can be described in terms of speed with the change in position of the body per unit time. For example, a man is running at 10 meters per second, or by the velocity, which is the change in position in a particular direction per unit time. Example, a man is running at 10 meters per second away from the tree. From the tree, the man is running away with a speed of 10 meters per second at all times. So the speed and velocity of the man is constant. This is a uniform motion. In this figure, the man is also running away from the tree, but the changes in position in every unit of time are changing from 2 meters per second to 4 meters per second to 6 meters per second and to 8 meters per second. The speed and velocity of the body is changing. This is an example of accelerated motion. When the motion of the body is unidirectional, the magnitudes of speed and velocity are equal. Though speed is a scalar quantity, while velocity is a vector quantity. The units of speed or velocity are meters per second in the NKS system, centimeter per second in the CGS system, and feet per second in the FPS system. Other commonly used units are kilometer per hour, miles per hour, or mph, and inch per second. Now, thinking about speed or velocity, what are the differences between instantaneous velocity, average velocity, and change in velocity? From the tree, the man runs at speed of 10 meters per second from time sub 0 to time sub 3. These velocities v sub 1, v sub 2, v sub 3, and v sub 4 are instantaneous velocities. They are the velocities of the man at a particular point of its motion. The average velocity is the single velocity that can describe the entire motion of the man, which can be computed as the ratio of the total distance traveled and the total time of travel. Because the man ran 10 meters per second at all times, there is no change in its velocity. The change in velocity, delta V, is the difference between two successive velocities. In some situations where the initial and final velocities are the information provided, the change in velocity is the difference between the final velocity and the initial velocity. The change in the velocity is the difference between V sub 2 and V sub 1 and is 0. Let's have an example. A car is traveling along a straight road. The speedometer reads 30 kilometers per hour at time sub 1, 40 kilometers per hour at time sub 2, 50 kilometers per hour at time sub 3, and 35 kilometers per hour at time sub 4. After traveling in 15 minutes, the car covered 8.75 kilometers. A. What are the identified instantaneous velocities of the car? B. What is the average velocity of the car? C. What is the change in the velocity of the car from time sub 1 to time sub 2? The instantaneous velocities are 30 kilometers per hour at time sub 1, 40 kilometers per hour at time sub 2, 50 kilometers per hour at time sub 3, and 35 kilometers per hour at time sub 4. The average velocity of the car can be computed by dividing the total distance traveled by the total time of travel. Average velocity with the symbol bar V is equal to 8.75 kilometers. The total distance traveled divided by 0.25 hour, the average velocity is 35 kilometers per hour. The change in velocity from time sub 1 to time sub 2, delta V, is the difference between V sub 2 and V sub 1, which is 40 kilometers per hour minus 30 kilometers per hour. The change in velocity is 10 kilometers per hour. Now, what is meant by the average speed 35 kilometers per hour? This speed means that the car covers 35 kilometers in every hour. Let's move to the third way of describing motion. This man moves away from the tree with a speed changing from 2 meters per second to 4 meters per second to 6 meters per second to 8 meters per second at the same time interval. The ratio of the change in the velocity of the body and the time to change the velocity is known as acceleration, A. The equation for acceleration is A equals delta V over T. So what is the acceleration of the man? From the recorded instantaneous velocities, the velocity changed from 2 meters per second to 4 meters per second. The change in velocity is 2 meters per second. If it took 1 second to change the velocity, the acceleration is 2 meters per second squared. This quantity can be used to describe the motion of the body. A motion can be described in terms of acceleration, which is the change in the speed of a body per unit time. This is a scalar acceleration. Example, the man is running with a speed changing at the rate of 2 meters per second squared. Or a vector acceleration like this. A man is running away from the tree with a speed changing at the rate of 2 meters per second squared. The units of acceleration in the three systems of measure are MKS, meter per second squared, CGS, centimeter per second square. FPS, feet per second square. Other units of acceleration are kilometers per hour squared and miles per hour squared. Let's have an example. A car traveling at 5 meters per second increased the speed to 20 meters per second in 5 seconds. What is the acceleration of the car? The given from the problem are initial velocity of 5 meters per second, the final velocity of 20 meters per second, and the time to change the velocity 5 seconds. The required is the acceleration. The formula for acceleration is A equals delta V over T. The change in velocity, delta V, is the difference between the final and the initial velocity. Substitution and calculation. The change in velocity is 20 meters per second minus 5 meters per second. The change in velocity is 15 meters per second. This change happened in 5 seconds. Thus, the acceleration is 3 meters per second squared. The final answer is 3 meters per second squared. What does 3 meters per second squared mean? This means the velocity of the car increases by 3 meters per second in every 1 second. Increases because the acceleration is positive. If it happened to be negative 3 meters per second square, it will mean a decrease of 3 meters per second in the velocity in every 1 second. Generally, there are 2 types of motion based on the change in the position of the body. The first one is uniform motion. Notice that the change in the position of a body in every unit of time is constant. Thus, a body has uniform motion if it covers the same distance in every unit of time. The instantaneous velocities of the body are equal. If we calculate the average velocity of this body, it is equal to 10 meters per second. Thus, the average velocity of the body is equal to the instantaneous velocities. Because the instantaneous velocities are equal, the change in velocity is 0. And because the change in velocity is 0, the acceleration of the body is 0. How does the graph of distance traveled and time of travel looks like? It's a straight line graph sloping upward to the right. The slope of the graph line of distance traveled versus time is constant. And the slope is equal to the velocity of the body. How about the graph of velocity versus time? The graph line is horizontal line graph. A horizontal line graph has 0 slope. The slope of velocity versus time graph is equal to the acceleration of the body, which is 0. The other type of motion based on the change in position is accelerated motion. When the velocity of the body changes, either increasing or decreasing, the body is accelerating. Here, let's consider a constant change in the speed of or velocity of the body. It is classified as uniformly accelerated motion. The distance traveled changes, increasing or decreasing, in every unit of time. The instantaneous velocities are changing uniformly in every unit of time. The average velocity is the total distance traveled divided by the time of travel. The change in the velocity of the body in every unit of time is constant. The acceleration of the body is constant. the graphs of uniformly accelerated motion. The graph of total distance traveled against the total time of travel is a parabola that opens upward. This suggests a direct square proportion. The graph of total distance traveled against the square of time is a straight line graph sloping upward to the right, suggesting a direct proportion between the distance and time square. The slope of the graph line of distance versus time square is 1/2 of the acceleration of the body. The graph of velocity versus time is a straight line graph sloping upward to the right, suggesting a direct proportion between velocity and time. The slope of the graph line of velocity versus time is equal to the acceleration of the body. How about the graph of acceleration and time? The graph line of acceleration versus time is horizontal line graph. That horizontal line graph suggests uniform or constant acceleration. If you want a more detailed discussion about graphs and relationships, there is a video lesson on graphs and relationships in this channel. There will be a separate video lesson discussing all about uniformly accelerated motion, or what we call kinematics. Wait for that video, and that is coming very soon. That's all about describing motion. So let's test your understanding. How far have you learned this topic? Following are 20 items you have to identify. After identifying, to check if that is correct, find the word from the jumbled letters on the table. I suggest you have a pen and paper ready for you to write your answers. Pause the video every group of items to give you more time to think and hunt for the words or phrase in the table. Okay? Good luck and enjoy while learning. Let's start. This is a word hunt. Find the words or phrase, no space between words, that are defined below. The words are written either horizontally, vertically, or diagonally on the table. Once all the items are displayed, pause the video until you have answered all and find the words on the table. Continue to the next items when done. Here are items 1 to 4. Continue with item numbers 5 to 11. You may pause the video to give you more time to play. Continue with item numbers 12 to 17. You may pause this video to give you more time to play. Here is the final 3 items, 18 to 20. You may pause the video to give you more time to play. Hope Hope you have completed all your answers. In a few seconds, the answers will be displayed on this table. Ready? The answers are displayed in this table. Some are horizontal, to the left or to the right, vertical, upward or downward, and diagonal, upward or downward. Check your answers. Are you done with the answers on the table? Here are the answers to the 20 items. How many of the items you got and found correctly? Hope you got all the correct answers. Hope you have attained what you are supposed to learn from this video. Be able to describe a motion properly and correctly. If you learned from this video lesson and you feel that other students may also learn from this, like and share this video lesson. If you have not subscribed to this channel yet, it's time for you to click the subscribe button below. More video lessons are coming to you. Thank you for watching. God bless and good luck.